So what we're going to solve today is a 2 by 2 matrix. So there are two ways to solve a matrix. First of all, if you remember the movie The Matrix, when you had the black screen and the green numbers going up and down, that was kind of like what we're about to do, but we're not going to do anything as extensive as that. So there are two different types of ways to solve a matrix. The first way is substitution, which we're about to see now. So, and we'll talk about the second way later. So substitution, let's say for example they give you x plus y equal 4, and they give you y equal 3x. So the purpose of a matrix is the first equation, x plus y equal 4, you have to pick a number for x and pick a number for y, so that when those two numbers add up they equal out to 4. Similarly, the same x and y you picked in the first equation, you have to be able to plug it into the second equation, and it has to work out as well. One way to do this without guessing, it's easy to guess this problem, but they have problems in the book where there are fractions, or they have problems where there might be fractions and they're harder to guess. So a way to get around guessing is to do a substitution. Substitution is pretty much if you have one of the letters already solved for. So when you look at this second equation, you already have it in terms of y equal. So it's already solved for y. And remember, whatever this y is the same thing also. So if the second equation has y equal 3x, you can plug it into the first equation. And what you have is x plus 3x equal 4. And this is easy to solve because you have it all in terms of x. So when you add x and 3x, you get 4x. So you have 4x is equal to 4. And to solve for this, you divide both sides by 4. And you have x is equal to 1. So this gives you one letter. So you already have one letter, which is x. Because you got two different equations, remember, whatever x is in the first equation is also the same thing in the second equation. So if x is 1, all you really have to do is plug it in. And what I'm going to do is I'm going to plug it into the second equation because it's already got x by itself. So y equal 3 times 1. And that gives me 3. So therefore x is 1 and y is 3. Because if you check it, 1 plus 3 is 4. And 3 is equal to 3 times 1, which is 3. Let's see another substitution problem. So let's say we have x plus 3y equal 8. And we have y equal 2x plus 9. Or 2x minus 9. Okay. If you look at it, the second equation is already solved for y. It's already in the form y equal. So I'm going to plug that in the first equation. So what I'm going to have is x plus 3, open parentheses, 2x minus 9, because that's what y is, close parentheses, equal to 8. And so to solve this, you have to bunny hop 3 through. And so you're going to end up with x plus 6x minus 27, and that's equal to 8. And so to solve it, you add up x and 6x, and that gives you 7x. You have a minus 27, so to get that to the other side, you have to add 27 to both sides. And so when you add up 8 and 27, that gives you 35. So you have 7x is equal to 35. And so to solve for x, you divide both sides by 7. And you end up with x is equal to 5. So you got x. All you have to do now is get y. Well, the easiest equation to solve it in will be the second, because it's already in the form y equal. So all you have to do is plug in x into that equation, and what you're going to end up with is y equal 2 times 5 minus 9. 2 times 5 is 10, so you have y equal 10 minus 9, which comes out to y equal 1. And so you have x is 5 and y is 1. So here's another equation. Let's say that we have 2x minus 3y, and that's equal 8 minus 2x. And then the second equation, we have a 3x plus 4y, and that's equal x plus 3y plus 14. Now this looks weird because we have a lot of things on both sides, but what you can do is put all your x's and y's on one side and all your numbers on the other. So what we're going to do is we're going to add 2x here, and that's going to bring it to the other side, and that gets rid of it on this side, and what you end up with is you end up with the 4x minus 3y equal 8. That's that first equation. On this side, on the second equation, we're gonna subtract x, and we're gonna subtract the 3y from both sides. So you subtract x and you subtract the 3y, and that gets rid of the x and the 3y on the right side. And what that's gonna give us, that's gonna give us a 2x plus y equal to 14. And remember, we're still solving it by substitution, so what we're going to do is I'm going to take 2x from this second equation, the 2x plus y equal 14. I'm going to subtract the 2x from both sides. So what that gives me is y equal a negative 2x plus 14. That's what my second equation is. So this is my first equation here, not to lose track, and this is my second equation here. So if I say that y is equal to negative 2x plus 14, then the other y in the first equation is equal to negative 2x plus 14. So what I have is I have a 4x minus 3, open parentheses, minus 2x plus 14, close parentheses, equal to 8. And so when I bunny hop the negative 3, I'm going to have a 4x plus 6x minus 42 equal to 8. And 4x plus 6x gives me 10x, so I have 10x minus 42 equal to 8. And so how do I get this negative 42 to the other side? Well, I have to add it. So what I'm going to do is add 42 to both sides. And moving the equation back up to the top, it's going to give me a 10x equal to 50. And to get x by itself, you divide by 10, and what you end up with is x equal to 5. So you have one letter, which is x. My equation 1, if you can recall, you don't have to use the first two equations they gave you. The equation 1 that says 4x minus 3y equal 8 is equal to the first equation, which was 2x minus 3y equal 8 minus 2x. They're equal. So the easiest equation for me to use would be number 2 to plug x back in. So when I use this one, I'm going to have y equal a negative 2 times 5 plus 14. Negative 2 times 5 is a negative 10, so y equal negative 10 plus 14, and negative 10 plus 14 comes out to a positive 4. So I got x is 5, y is 4. Let's say they give you fractions, so let's say they give you y equal 1/3 x plus 2/3. And then the other one is y equal 5/7x, 5/7x minus 2. Well, that minus 2, you can make that a minus 2/1. So when you look at this, the common denominator, you can make everything over a fraction, so the y will be over 1 and this y will be over 1. The common denominator of 1, 3, and 3 is 3. So to get a 3 over here, you multiply top and bottom by 3. And the common denominator of 1 and 7 is 7, so you have to multiply top and bottom here by 7 to get a 7 on the bottom, and the top and bottom here by 7. So what you end up having is of 3y over 3 equal 1/3, or you can call that x over 3 plus 2 over 3. And then at the bottom, what you have is you have a 7y over 7 equals 5x over 7. if ever you have x on the side of a fraction, you can always put it on the top just to be safe. Minus 14 over 7. So, if ever you can get all the denominators the same, all you need is to write the top. So what we're going to have is a 3y equal x plus 2 and 7y equal 5x minus 14. And we're still in the substitution phase, so what I'm going to do is I'm going to bring this 2 on the 3y equal x plus 2 to the other side. And so what that's going to give me is that's going to give me a 3y minus 2 equal x, and then just rewrite the other equation, which is 7y equal 5x minus 14. Okay, now if x is equal to 3y minus 2, then I can plug it into the second equation, and I'm going to have 7y equal 5 open parentheses 3y minus 2 close parentheses minus 14. So doing that calculation, you got to bunny hop to 5, and you're going to have 7y equal 15y minus 10, and then bring down to minus 14. Now the like terms on the right side, negative 10, negative 14, that's going to add because those are two negative numbers. So what you're going to have is a 7y equal 15y minus 24. And so your goal is to try to get all your numbers on one side, all your letters on the other. So you can subtract 7y or 15y from both sides. And so when you do that, you're going to get a negative 8y equal minus 24. And to get y by itself, you divide by negative 8. And you end up with y is equal to positive 3. So you got y. Now what you need to find is you need to know what x is. Now if y is 3, and if you recall this top equation, 3y minus 2, you plug y in, just looking at the top, and we're going to have a 3 times a 3 minus 2, which is 9 minus 2, which comes out to 7. And so therefore x is 7 and y is 3. The next type of problem, or the next type of way we're going to